Hi, I'm an old guy and I do maths. And here is our problem. As you saw from the header, we have an equilateral triangle. It has an area of 25 centimeters squared. And we want to know what the measurements of its sides are. Now, the traditional way of figuring out the area of a triangle is height times base over 2, or half base times height, whatever way you want to put it, and that we're told equals 25. Now, the height of this we can obtain as an expression. I'm pretty certain we can't get a number, but we can get an expression. I don't know how helpful that will be. It's possible that it might be. It's not how I'm going to solve this. Because my fear is that we might wind up looking for two variables, and even with an expression for height that might well contain the value for a base. And I don't want to do that. That's messy. I think there's a better way, and we can use one of the characteristics of an equilateral triangle to get out of this predicament. We're also going to use a different formula. So there is a less known but equally valid formula for the area of a triangle, and it's half AB times the sine of C. And when I said we were going to use the innate properties of an equilateral triangle to solve this, what I was talking about was the fact that A and B, the side lengths, will be the same, whichever ones we take. And all the angles are the same, so we can take any of these angles. So if we tidy this up, we get half A squared, because A is equal to B, so we can just square A. It doesn't matter which one of these sides we call A, we'll call that A. That means that that's angle A, this is side B, let's do that. This is side C, so that is angle C, times the sine of 60 degrees, and that is going to equal our area. Okay, well, we know what our area is. So we have A squared over 2, that's a half A squared, times the sine of 60 degrees equals 25. So you can see where I'm heading with this. So A squared over 2 is equal to 25 over the sine of 60 degrees. Keep moving down the page. A squared is equal to 2 times 25 over the sine of 60 degrees. A is going to equal the square root, it's going to be a positive number, of 2 times 25 over the sine of 60 degrees. And that is an exact value, I assume. I'm going to try it and see what I get. I'm probably going to get a really ugly decimal, but I'll try this. So the first thing I'm going to do is I'm going to divide 25 by the sine of 60. And I'm already into surd territory, I think. 25 divided by the sine of 60 degrees. Yeah, I'm in surd territory. There we are. Okay. That's 25 divided by the sine of 60 degrees. I'm going to multiply that by 2 here. So times 2. That's going to give me 100 root 3 over 3, I assume. Oh, nice. I've got myself a decimal. We're in business. So you can see there it's 25 divided by the sine of 60, gave me that expression. When I divided it by 2, I got this number. No picking what this calculator will do. Now, I need to find the square root of that. So the next thing to do is to raise that to the power of a half, which is the easiest thing to do on this calculator. And what we get is we get 7.598. So let's call that 7.60. Okay, so that's a rounding to 2 decimal places. Now, that is the length of A. It's also the length of B, and it's the length of C, and that is how we figure this out. Now, you can use this to figure out the height of this if you want. If you want some extra work to do, you can use that to figure out the height of this. And you can put the numbers into this formula and just check. But I'm fairly confident that that is our answer, or at least approximately our answer, centimeters, in my bad handwriting. Thanks very much for watching. I hope you found this interesting, if not useful. If you did, please like and subscribe, and I'll see you next time. Bye.